Hey everybody, I'm back. I know those concave mirror ray diagrams and problems can be a bit challenging. You'll find that the convex mirrors are a little bit easier to handle. There's still some challenging tricks to making the ray diagrams and a little tough algebra. But other than that, you should find that they have a lot more similarities between them than some of the other ones. So let's give these a try. We'll start out with number one on our convex mirror problems here. We're talking about the radius of Earth, and we're talking about the Pacific Ocean as a giant convex mirror. So we have our givens listed here. One critical thing to notice is that when you have a sphere, its radius represents c. So half of that value would be f. And then another critical thing is if you review your sign convention chart, notice that we need to have negatives in front of those whenever we have convex mirrors. R and C and F are always negative. I notice that I have to keep everything in the same unit, whatever it is, as long as, and there's the bell. The same unit applies here, just make sure everything is in kilometers. We go ahead and solve here. I actually was able to find Q first. This negative Q indicates that we have a virtual image. Q is not what I wanted. I wanted to find the image height, the diameter of the image, essentially the size of the image, but I'm able to use Q in this other equation to find H prime. Let's switch over to the ray diagram and see how that works. All right, so here's the ray diagram for number one on the convex mirrors. You can see that the same rules apply. I went ahead and copied over the givens here just for reference. Notice that F and C are now behind the mirror. That is true because this is a convex mirror and because F and C are negative. C still has to be twice as far away as F. I have the P here, which just needs to be farther away than either one of those two. That was really just, you can tell that that has to be true from these givens. Let's take a look at the rules. We have parallel and then through F. Did it actually go through F? No, it didn't, but it's lined up as if it did. Second rule is through F and then parallel. Did it actually go through F? No, but it's lined up as if it did. Through F, parallel, and then finally this one is through C. Once again, did it actually go through C? No, but it's lined up as if it did. Where is the image? That's the next question. Well, we do know it's a virtual image, and to figure out where it is, we can't actually see the rays come back together, but we have to take a look at where it looks like they're coming from, where it looks like they would come together. So to do that, we're going to trace the three reflected rays back, just like we did on the previous assignment when we had a virtual image. We have to trace this ray back because it's reflected. We have to trace this ray back because it's reflected, and then we have to trace this ray back because it's reflected. And then once we do that, we should be able to tell where the image shows up. It's going to look like there's an image right here. This is where we would label Q. It's a virtual image in that it's behind the mirror, so we could not actually put a piece of paper there, but it looks like there's a smaller version of the real thing there. Switching over to our online simulator, if we set this up in such a way that we move the object over here, and also move the focal point and the radius of curvature, the center of curvature over here, we can see that that makes sense. Although this simulator doesn't include the rays that you would trace back to make the image, you can at least get a general sense that your ray diagram and your image makes sense here based on what you know should happen. All right, we'll move on to number 6 now. Number 6 deals with something fun, the largest starfish ever discovered, whatever. What we really care about, though, is the fact that that is the object size, so we list that as our given. The other givens are listed here. We're actually asked to find the radius of curvature of the mirror. So we're asked to find C. Well, we can find C if we know F. We know that C is twice as much as F, and so that's going to be kind of our philosophy here. You can see that, and there's the bell again. You can see that we need, we also have too many unknowns in this. So we're going to use two equations, two unknown. A couple of the problems work this way as well. You can see I chose to use this equation to solve for Q, substituted this statement in for Q to get this statement, did some algebra to make it say F equals everything else, plugged in my values, used the proper rounding rules for sig fig, and got F as a negative number. I'm going to double that to get C, which is the answer. Lastly, we'll show you the ray diagram. You can see that I traced the three reflected rays backwards in green. Where they all meet, that's where we would draw Q belongs there. That's actually Q, which is where the object is located. I'm sorry, that's where the image is located.